Bienvenidos, Ushamdi, and welcome CTS230, Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3, or the Cisco Networking Academy Scaling Networks version 6 course, and this morning's video tutorial and solution set is going to be on Packet Tracer Activity 10.2.2.3, where we're going to be troubleshooting single area OSPF v2. So let's go ahead and dive in and take a look at our topology here. This should be pretty familiar by now. All of the 10.x packet tracer activities are sort of based off of this triangle topology where we've got LAN segments behind routers 1, 2, and 3. And router 2 is our gateway to the internet. So, as you can see, we're not given much of anything over here other than the fact that we're being told that we've got issues of reachability. So, let's go ahead. We'll simply start over here. I'm going to start with PC1 off LAN segment 1 behind router 1, and then we'll work our way from there. So, typically we've got a user here that's at PC1, and they're going to say, you know, I can't ping the internet at 64.100.1.2. And you can see that we're sending ping packets out and we're getting an ICMP destination host unreachable, timeout, host unreachable. And if this next one is a timeout, yeah, so there's a very good possibility that we have a loop in the network. So how would we check that? Well, we could use traceroute, or you would type in traceRT on Windows. And let's trace out to 64.100.1.2. Let's see what happens from the PC's perspective, and if this is a loop, my guess is, and there you go. So as you can clearly see, we're going to 172.16.1 and then 172.16.1, and then that times out. My guess is we should see 172.16.1 again, and we do. Yeah, so clearly we've got connectivity issues, reachability issues on working our way out of the environment. Now, some of the things that we talked about during the previous packet tracer activities were the requirements in order for OSPF speaking routers to form adjacencies. And so we know what some of those requirements are. We know that the subnet mask needs to be the same. We know that the hello interval and the dead interval need to be the same. We know that the MTU needs to be the same. And so that is where we're going to start our troubleshooting. So I'm going to come here to router 1, and this is where we'll begin in earnest to check and see what's going on. Now, some of the commands that are very, very helpful, and in fact, let me stretch this out here, give us a little more room to work with. Some of the commands that are extremely helpful, and these should be on your, or in your OSPF troubleshooting tool chest right away. The first is show IP OSPF Neighbor, and then a show IP OSPF Interfaces, show IP OSPF, or just show IP OSPF, and then show IP Protocols. And so those 4 commands right there are very, very helpful. So show IP OSPF Neighbor specifically, and we can see here right out of the gate, we can see that we've got an issue. So it appears that we are fully adjacent with router 2, but where is the entry for router 3? And if I slide this a little over to this way, you can see we should have an adjacency here with router 3, and we don't. So let's begin there. I'm going to say show run. I would say show run begin, you know, serial something something something, but I'm looking for the IP address configuration here. Let's make sure that we're configured correctly. So we're troubleshooting this neighbor relationship right here because we've identified that that neighbor relationship doesn't exist, and so let's figure out why. So 192.168.10.4, okay, so I'm 10.5. That means that router 3 should be 10.6. And again, just starting at the basic IP, oops, we did not want that. Starting at the basic IP addressing to see if that might be an issue. So let's check and see serial 000 on router 3. It is a /30 and it is 10.6, and the clock rate is set to 64,000. And so I'm 192.168.10.5. So let's check. Do we have reachability? So 192.168.10.6. And we do. So this is what we call sort of, I like to call it splitting the difference, right, in the OSI model. So we've got reachability, or we have reachability at layer 3. So everything is good up to layer 3 from the IP address perspective. And this is a good sign, because now what this means is we can probably turn our focus to OSPF, something in the OSPF configuration or a setting that might be impacting OSPF forming the adjacency. And so on router 1, let's say show run, I would say show run pipe it to section router OSPF. But here we go. So let's take a look. So we've got router OSPF 1. Remember that process ID, that is a locally significant value. We then have log adjacency changes. We've got passive interface, and we'll keep an eye on that, right? We want to make sure it's not passive interface default. That could be a problem, but it's passive interface gig 00, and that's correct because, again, there are no OSPF speaking routers out here beyond router 1, so we want to passive that interface. No need to send or multicast hellos out to 224.0.0.5. Okay, so here are the network statements. What do these look like? So 172.16.3.0, that'll be for the segment between I can't see it, but I'm assuming routers 2. Excuse me. Routers 2 and 1. So that looks good. 172.16.1/24 area 0. That is good. That's our LAN segment. And then network 172.16.10.4/30. Now, when I look here, what is that subnet right there? Do we have a 172.16.10? No, we do not. So we know right now that this is probably, if not the root cause, it's a contributing factor. Because again, we've only looked at router 1's OSPF config. There may be something on 3 that is also causing an issue here in addition to this. But we definitely know that is not correct. So let's get into global config and let's say router OSPF 1. And we're going to say no, and I'm simply going to cut and paste here. And we're going to remove this statement because this statement does us no good in any form or fashion, right? So that statement is completely irrelevant. We have no 172.16.10.4/30. What we do have is a 172.16.10. I'm sorry, end up repeating what we were doing. 192.168.10.4 0.0.0.3 area 0. Now the expectation will be that when we hit enter here, and let me slide this up ever so slightly so that you can see, we should get some points and we should see an adjacency. Yeah, 34 points in fact. And the adjacency goes from loading to full. So now on router 1, I would say do show IP, or actually do show IP OSPF neighbors. And as you can see, we now have 2 full adjacencies, as we should with both router 2 and router 3. But does that give me any connectivity over here? Let's see what we've got going on over here. So we go to 172.16.1, and that's the default gateway. That is the LAN interface right here, gig 00 on router 1. And then we end up back at 172.16.1.1. And then my guess is we'll see something similar here where the request will time out. And then we probably come back to 172.16.1.1, and we do. So hasn't solved the problem. Well, we wouldn't expect that it would, right? But we're kind of taking a logical approach here, you know, making a fix and then checking to see, are we working right now from the perspective of PC1? But we know from the completion percentage that we've got a little more work to do. So that takes care of the adjacency between router 1 and router 3. So on router 1, we know that we can ping router 1, do show IP interface brief. I know I can ping the 172.16.1.1, and we know that traceroute is getting us there, but then it's not going anywhere else. So what might the problem be? Well, do show IP route. Let's see what the routing table looks like here on router 1. as you can see, we don't have an entry for the 64.100.1.2 or the .1.0/24 or whatever that subnet mask is out there. It doesn't give us a subnet mask, but whatever that subnet mask would be, we don't have a network statement for that specific network. Now, when we look at this, what do we see? 172.16.2. So I know the LAN segment behind PC or behind router 2. And then I've got 192.168.1.0, and that's the LAN segment over here behind router 3. And then I know about the 192.168.10.8, which is this network segment right out here. Now, I don't see OSPF information for that transit segment, 172.16.3.0, because again, I'm directly connected, lower administrative distance. Same reason I don't see an OSPF entry on router 1 for 172.16.10/24. It's directly connected, lower administrative distance. So let's go ahead and check. So can I reach, do ping, and let's see 172.16.2.10. Is that the PC? What are the 10.2? Okay, so Control-Shift-6. Can I ping? So I can ping from the router, I can ping the PC2. Can I ping PC3, which is going to be 192.168.10.2? And so we have an issue here. Something appears to be up. I can get behind router 2 to the LAN segment here. And I'm on router 1. And so from PC1, let's try that same thing. Can I ping over to 172.16.2.2? And we can, not a problem. And now let's see, can I ping 192.168, and let me make sure I've got this IP correct. It should be, oh, .1.2, sorry about that, .1.2. So from the PC, can I get there? And okay, good. So we have connectivity from the PC, and if I get the right IP address in here, .1.2, we've got connectivity. Right? So it looks like internally things look good, but again, excuse me, I'm either going to have a more specific route on router 1, a static route, or I'm going to have what? And I just highlighted it right there. Remember, this is from the previous packet tracer activity. We're going to need to have some way to get out of the local segment or off the local segment. And we would typically use a default gateway for this. So if we're not receiving the default gateway and we are fully adjacent with router 2, who would be giving us that default route, because again, router 2 is the only exit point from the environment here, we would expect that on router 2 we would see a default information originate as well as a static default route, the IPv4 IP route quad zeros. And let's check and see what we see here on router 2. So show IP route. And as you can see, there is a static route here, right? Connected to serial 010. Let's see, why are we not getting that in OSPF? And again, I'm making the assumption that that is what they're going to want because we've seen this in the previous activities. And obviously, without connectivity to the outside world from the OSPF domain, we need some way to get out. And this is how you would do it. So we have a passive interface for gig 00. That's all good, right? We've got our 3 network statements here, and these look good. Yeah, these all look good. And here is my IP route. But what am I missing? Exactly, I'm missing router OSPF1, the default information originate command. And let's see if we're rewarded with some points for that. And we are. We get 33 points. Excuse me, because again, no one is going to get off of the local, out of the local OSPF domain if we don't have a way or have routing information in our routing table here on router 1 that tells me, hey, if you don't know where you're going and you don't have a longer, more specific match, come to 172.16.3.2. So now let's go over to PC1 and let's check and see, can I get out to 64.100? Now we go to 172.16.1.1, which is our default gateway, router 1. We then go to 3.2, which is router 2, who then takes us out to 209.165.200.226, and then we make it to our destination. So let's ping 64.100.1.2, and we have connectivity. Now we have connectivity from PC1. Let's check PC2 and see if PC2 feels the same way. Can I ping out to 64.100.1.2? And we can. And now finally, let's check PC3. And my guess is, again, knowing packet tracer and these activities, 64.100.1.2, we fixed something on router 1. We've fixed something on router 2. Where have we not fixed anything? We haven't fixed anything on router 3. So my assumption here is incorrect, is that we can get out of the network, but clearly something is still not right. And so back on router 2, let's see what things look like here. If I say do show IP OSPF neighbor, because we know something else is wrong. And this is going to be the dead giveaway right here, is that router 2 only has an adjacency with router 1. So there's something wrong on the link between router 2 and router 3. And so if I was to go back to PC3, if I trace to get to the 64.100.1.2, rest assured that we know that right now that traffic is going to do this. And that is not what we want. We would like to see the traffic just go like that, right? To come to router 3, and instead of going to router 1 and then to router 2, is to come to router 3 and then go straight to router 2 and out, because that's going to be the shortest path. So on PC3, if we pull PC3 up and I say trace RT for trace route, 64.100.1.2, yeah, you can see we go to 192.168.10.5 for the second hop, and that's router 1. Then we go to router 2, then we go to the 209.165 Internet Cloud, then we get to our destination. So we've got an issue between 2 and 3. So let's take a look here on 2, do show run, and I'm coming down to look at a couple of things. I'm looking at the IP address here, right? Making sure the subnet mask is correct. So 192.168.9.10, that is correct, I believe, if I move over a little bit. Yep, so we're .9. We have our clock right. Let's look at the OSPF config here. Is the network statement correct? Do we have the right wildcard mask in the right area? And we do, and that is the right network. We've got the default to information originate. So router 2 looks good. So that tells us that probably over here on router 3, if we go from user exec to privilege exec, we'll say show run. And actually, before we do a show run, show IP OSPF neighbors, and we see that that's it. That's the only neighbor that we have. If we say show IP OSPF interfaces, right, we can take a look, and this is the interface here between router 2 and router 3, that 192.168.10.10, that's our IP address. .9 is router 2. And so we could take a quick look in here. We could see, yeah, it's point-to-point, obviously a priority of 0. It's a point-to-point link. No DR, no BDR. The intervals, the hello is 20, the dead is 40, and the wait is 40. And now this should be a red flag for us, because we know that those are not the defaults. And we look at serial 001 here, and we see that we've got IP OSPF hello interval 20. Now, did we have the hello interval set over here to match that? And so the answer is no. So we know what the issue is. Now the question becomes, is Packet Tracer expecting us to match the hello interval of 20, or are they expecting us to remove the hello interval of 20? And my guess is they want this removed. So we'll go into global config. Whoops. We'll go into global config, interface serial 001, no IP OSPF, hello interval 20. And that should actually get us the points, and more importantly than the points, let's give it a second here. We should see within 10 seconds, and there it is that the adjacency comes back up and we go from loading to full. All right, well, that is it. Again, take a methodical approach, right? We used like what I like to call split the difference, right? Is to check for connectivity at layer 3 and then kind of work from there. And think about the things that would cause an OSPF adjacency to not establish. The timer intervals, the network statements, the interfaces being up or down, right? MTU, subnet masks. Those are the things that we're going to look at, or that you want to look at, when you don't see that the adjacency is forming. Passive interface is another one. If we had passived any of those serial connections, we would not have had connectivity. So now we've got full connectivity. And if we were to come to router 3, to PC3, if I was to trace route out now, you can see that we jump to 10.9, that's router 2, then to the cloud, so we take the shortest path out of the environment. All right, well, that is going to wrap up packet tracer activity 10.2.2.3, where we troubleshot OSPF v2 in a single area configuration. All right, guys, thanks so much for watching. Make sure you're studying for that final exam on Tuesday night, and I will see you soon.